In this video, we'll be going over how to design crossovers. So to get started, I have created an alignment of an existing track, and you're going to need a turnout block that for the crossover that you plan to use. So to get started, we're going to need our second track, our proposed track, or whatever um, the parallel track that we want to build the crossover between. So I'll offset the existing track by, let's say, 15 feet, like that. And then I'm gonna just create a new alignment out of it. And let's call this siding. And everything else is good. Okay, so typically you want to follow regular turnout rules when you're placing crossovers. So that means you don't want to place crossovers or turnouts within horizontal curves, and you don't want to place them within vertical curves either. So first we'll start with the horizontal. So ideally I want to start have the point of switch at least 100 feet from the end of the curve. So I'm going to draw a circle that's 30.5 meters from the end of the curve. And I'll just place it so that the point of switch is right there. And I'm going to rotate it into place using reference. So it'll look like that. And how it works is you want to use the bearing of your turnout, the divergent leg of the turnout. So I just drew a line, and you can use a construction line if you want. And since these two tracks are parallel, the intersection will be where your PI will be uh, of your crossover. So I'm going to rotate this into place, uh, just like that. And that is a basic crossover. So one thing you'll need to ensure is that the two tracks are parallel, and since we did an offset, should be parallel. And then to make sure that you pick the PI of your turnout where your bearing of your um, turnout meets the other track. So um, the overlap between the long ties is just a function of your track center. So since I used a 15-foot, there's just a little bit of overlap. If I use like a 14-foot track center, there will be more of an overlap and vice versa. So now I'm going to show you how to do the vertical design of this. I'm going to split the view up, and I just have this um, I have this profile made. Um, just for demonstration purposes. Let me just change the scale. Okay, I'm gonna turn on my station tracker so you can see what's going on. Um, so you could see the start of where we placed the turnout is actually within this vertical curve. So that will not work. This is a profile for the main line. Um, and the profile for the siding can be slightly different, so we can potentially make this fit still. So one thing to make, one thing we can do is let's figure out where we placed this turnout. It's 123.7. So if I do 123.7 and pick that, I like to just copy this in so I can see the extents. And you can see that by the time we place the second turnout, it'll be within the vertical curve. So we got two options here. One, we can shift the entire crossover so that we're clear of this vertical curve. Second option, we can do our siding profile so that the vertical curve is slightly shorter. So I will go over that really quickly. I'm going to create a new profile for the siding. Let's do major grids. And I'm just going to show some elevation here. Okay, so what I will do is I'm going to project this mainline profile to our siding. And then I'm going to draw out our tangents, vertical tangents. And let's figure out our intersection. And then create the new profile for the siding. So siding TR. Let's do design. Like this. So now what we want to do is figure out where our turnout is. So let's create a station label. So that one's 178.35. Of course, you probably want to design to a millimeter. Just for demonstration purposes, so I'm gonna design to the nearest centimeter. We'll do that. And you'll see the two tracks. There is a delta there just because there is a vertical curve, but we will fix that. So what we want to figure out is if this is our PI, where do we want our end of our curve? So if we want to give a little bit of buffer between the PS to end of vertical curve, let's say about 5 meters. Depends on, let's do 25 feet. So that's 7.62 meters. And now we can do a measurement between our vertical PI and this point. We can see our vertical curve can be twice this length. So we can do 36 times 2, 72 meter long vertical curve here. So I'll just do that. 72 meters. And there we have it. This is assuming that 72 meter long vertical curve is sufficient for this track. If it's not and you need to increase the length, then you're going to have to shift this crossover further to the west to make this work. And of course, you can continue down with this profile, but the last thing that I want to show you is the profile for the crossover itself. So typically you want to do an alignment and profile for the crossover. So I will do that really quickly. Let's call this crossover. No labels for now. So what you want to do is select your point of switch select your PI of your turnout, select the second PI, and then select your point of switch. So this is the alignment for your crossover. And what we will do is we will create a profile for it. And if you did your siding profile correctly to match your mainline profile, everything should line up. So we'll do we'll do that. You notice it's very short. And what I'll do is I'm gonna superimpose. I'm gonna superimpose this profile, the siding profile, and I'm going to only select the PS to PI section. So just this little segment here. Okay. And then over here, you have to project the other profile, the siding profile. So I'm going to go in here and select this one. And then destination profile. I'm going to start it there. And I will end it here. Okay, so this is our starting point, and this is our end point. So if we did this correctly, these should line up perfectly, and it does. So that, okay, so we still need to do the actual crossover profile. And it would just be like that. So let me just apply some labels. So the grades match. There are no vertical curves within the profile of the crossover, so that is good. And that's how we want to design crossovers. I also want to go over how to design a crossover for two existing tracks. So I've created these two tracks. What we want to do is figure out where we want to place the crossover. So let's say we want to place it um, in this little bit of tangent between the two vertical curves. So I'm gonna put this crossover or turnout here, and I'm gonna just put it on the other end as well. And then rotate it. And that is the basic crossover horizontal design. Now we'll move over to the profile, and similarly, we want the profile, the profiles of the two tracks to match up. So first off, I will superimpose the main line into the siding. And you'll see in this example, the main line is slightly higher than the siding. For a crossover to be placed, we need the two track elevation to match up and also the grade to match up. Right now, it looks like the grades look good, but there is a difference in elevation which we will have to fix. So what I'm gonna do is I'm gonna lift the siding just in this area by using these two vertical curves. So what I will do is I'm gonna make the dark blue line match up with the cyan. So over here, we're gonna come in at the same grade and elevation of the siding, but I want it to match the main line grade and elevation through this area where we're proposing to have the crossover. So we'll do something like this. So I'm drawing some lines so that we can figure out where the vertical PIs are. And over here, we want to continue with the siding profile. So notice that in this area, we're still matching the siding, but in this area, we're matching the main line. So once we have that, I'm going to create a new profile. We'll call this proposed siding TOR. And let's do layout. And we're just connecting the dots now. Oh, okay. So now we put in the vertical curves for our reprofile. Let's try that again. Let's do 100 meters. And there we go. So that is, you can see now the red track is our reprofiling, lifting the siding track to match the elevation of the main track. We're coming in lower and then we're at the exact same elevation at the main track here, and then we're going back down. So if we once again create a new alignment through the crossover, let's call this crossover. Just like before. Now the hard part is done. So this, if we did everything correctly, the profile should look correct. So once again, I'm going to superimpose the various tracks that we have. So this is the main line. So I'm going to superimpose the mainline profile. And I'm only selecting the PS to PI. Like that. Here, I'm going to superimpose both profiles so I can show you what it looks like. So I'm going to show you the existing siding. Now you'll notice, like before, if we were to extend this, you'll see that they don't match up. There is a bit of a gap because the siding track is lower than the main line. But if we were to superimpose our new track, just between the PS to PI distance, now they should match up correctly. And there you have it. So now that matches up, we can create crossover profile. And it will be a simple tangent. And that's it. Hope you found this video useful. Thanks for watching. Bye.